Hello everyone, welcome back to my Cellchat video tutorials. Today we continue our analysis to compare the difference of cell-cell communication network between two biological conditions, the healthy skin and the injured skin. So in today's video tutorial, I'm going to show you how to use the heat map plot, the bubble plot, and the wiring plot to compare the difference between the NL and the LS groups. First, we can use the heat map plot to compare the outgoing and the incoming signaling pathways associated with each cell population. Because we have two groups, the NL and the LS group, so we can get all the signaling pathways from both groups. So let's find the total number of signaling pathways. You can see from the values of all pathways, we have 48 signaling pathways in both groups. So now we can use the net analysis signaling row heat map function to plot the aggregated outgoing and incoming signaling pathways for each cell population. First is for the NL group. We know the NL group is the first group, so let's plot the heat map as heat map 1 for NL group. Then we can do the same for the LS group and we plot it as heat map 2. Now we can visualize both heat map together. Let's zoom in. You can see the overall signaling patterns for the NL group on the left hand side and the overall signaling patterns for the LS group on the right hand side. So here is the list of all the ligand, and the cell types are listed in the bottom. You can see down here from previous analysis, we know 6 signaling pathways are not presented in the NL group, and also the PTN signaling pathway is completely downregulated in the LS group. On the right hand side of each plot, you can see the contribution from each signaling pathways to the overall cell-cell communication network. So the relative strength of each signaling pathway in different cell types was shown from 0 in white color to 1 in brown color. You can see from the bar chart on the top, the overall signaling pattern in each cell groups in the LS group is stronger than the NL group. So in this heat map, the overall signaling pattern contains both incoming and outgoing signaling strengths. We can also use the heat map to plot the outgoing and the incoming signaling strengths separately. So first we can plot the outgoing strengths for the NL group as heat map 3 and plot the outgoing signaling strengths for the LS group as heat map 4. Then we can visualize the outgoing signaling strengths for the NL group and the LS group together. So let's zoom in. You can see now it's the outgoing signaling patterns for the NL group on the left hand side and the outgoing signaling patterns for the LS group on the right hand side. Once again, you can see the outgoing signaling patterns are increased in most of the cell groups in the LS group compared to the NL group. So next we can use the heat map to visualize the incoming signaling patterns for the NL group and the LS group. First, we can plot the incoming signaling pattern for the NL group as heat map 5, and then plot the incoming signaling patterns for the LS group as heat map 6. Then we can visualize the heat map 5 and 6 side by side. Now we can zoom in. You can see the incoming signaling patterns for the NL group on the left hand side and the incoming signaling patterns for the LS group on the right hand side. So here we use the heat map to plot the overall incoming and outgoing signaling patterns for all the signaling pathways in different cell groups. We can also use the heat map plot to show the individual signaling pathways that we are interested in. For example, we can use the CXCL signaling pathway again. So let's set the plot as 2 to plot the NL group on the left hand side and the LS group on the right hand side for the CXCL signaling pathway. Now we can make a list to plot the heat map for CXCL signaling pathways for both NL and the LS group. Then we can use the draw function in the complex heat map package to visualize the CXCL signaling pathways in different cell groups. Let's zoom in again. You can see now we use the heat map to show the communication probability for the CXCL signaling pathways in each cell type for the NL group and also the LS group. Compare the NL and the LS group, you can see the CXCL signaling pathway upregulated in other cell types but possibly downregulated in the LC cell types. So this is just an example for the CXCL signaling pathway. You can use other signaling pathways to make a different heat map. We can also use the heat map to show differential interaction numbers and also the interaction strengths in each cell groups. To identify the differential interaction numbers and also the differential interaction strengths, we use the net viewer heat map. You can see there is a comparison argument in this function to compare group 1 NL with group 2 LS. So this is the default argument in the net viewer heat map function. If you look at the online tutorial, they didn't show this argument. So I put the comparison argument here to make sure that you know when we run this net viewer heat map function, we actually identified the differential interaction numbers and also differential interaction strengths. If we set the measure argument as a count, we will identify the differential interaction numbers between the LS group and the NL group. So let's plot the differential interaction numbers as GG1 and plot the interaction strengths as GG2. Here we set the measure argument as weight. Now we can visualize GG1 and GG2 together. So let's zoom in again. You can see the heat map for the differential number of interactions on the left hand side. So the red color indicates upregulated signaling pathways in the LS group and the blue color indicate the downregulated signaling pathways in the LS group, and on the right hand side are the differential interaction strengths. And again, the red color show upregulation and the blue color show downregulation in the LS group. So this is the heat map. Next, I can show you how to use the bubble plot to compare the communication probabilities between selected source and target cell groups. For the demonstration, we can set the source user as 4. We know number 4 is the inflammatory fibroblast, and the target cell groups as group 6 to 11, and they are immune cell types. Once again, we use the comparison argument in the net visual bubble function to compare the communication probabilities in the LS group with the NL group. So if we run this code, we will generate a bubble plot to show both upregulated and downregulated signaling pathways in the LS group. So here the plot looks very crowded. We can export it to the PDF and change the settings to make it bigger. Then we can easily to see the upregulated and downregulated signaling pathways in different cell groups. So let's preview the plot. You can see down here we generated a bubble plot to compare the upregulated and downregulated signaling pathways. And the red color shows the NL group and the blue color shows the LS group. We can use some examples to show you the upregulated and downregulated signaling pathways. For example, for the inflammatory fibroblast to the dendritic cell 2, you can see in the NL group, those signaling pathways is not identified, but it is upregulated in the LS group, and the C3 complement signaling pathway is presented in the NL group, but is further upregulated in the LS group. For the CCL5 ligand from the inflammatory fibroblast interact with the CCR3 receptor on the dendritic cell 2, you can see this signaling pathway is presented in the NL group, but is downregulated in the LS group. So use the bubble plot, we can identify the upregulated and the downregulated signaling pathways between the source cells and the target cells. So in this plot, we show both upregulated and downregulated signaling pathway in the same plot. We can separate the upregulated and downregulated signaling pathway in the bubble plot. So to do so, we can set the argument max data set as 2. So when we set 2 is the LS group. Using this argument, we will plot upregulated signaling pathways in the LS group. So let's make the plot. You can see now we have a new plot. We can export it to the PDF again, and we change the settings. Then we can preview the plot. You can see now we only show the upregulated signaling pathways in the LS group. For example, you can see down here the BMP4 and the BMP2 signaling pathways are not presented in the NL group, but they are upregulated in the LS group. And for the complement C3 signaling pathway again, you can see they are presented in the NL group but are further upregulated in the LS group. So when we set the max dataset as 2, we generate the bubble plot to show upregulated signaling pathways in the LS group. If we set the max dataset as 1, then we generate a bubble plot to show the downregulated signaling pathways in the LS group. Let's make the plot again. And here you can see the plot still looks very crowded, so we can export to the PDF again. And first change the parameters. Then we can preview the bubble plot. Now we only show the downregulated signaling pathways in the LS group. You can see down here, signaling from inflammatory fibroblast to dendritic cell 2 to LC cell types, the inflammatory T cells and the CD40 LG positive T cells. The NL group is located on the left and the LS group is located on the right. You can see for the CCL5, CCL3 signaling pathway, it is presented in the NL group but is downregulated in the LS group. Here, for the CSF1 to the CSF1 receptor, it is presented in the NL group but it's further downregulated in the LS group. So this is the bubble plot. Finally, I want to show you how to use the wiring plot to compare the signaling pathways. We can use CXCL signaling pathway as an example again to show the plot. So the wiring plot is a thread wrapper function. The plot gene expression function in the Cellchat package will plot the wiring plot. Because we want to compare the gene expression between the NL and the LS group, so we need to use the split by function. In order to compare the NL and LS group, we can have a look at the metadata for the Cellchat object. You can see in the metadata for the Cellchat object, the condition column and also the dataset column indicate which cell comes from the normal skin and which cell comes from the injured skin, the LS. So when we make the plot, we can set the split by argument as the conditions. Also, we can set it as the dataset. Here we use conditions, then we can make the wiring plot. So we generated the wiring plot to compare the CXCL signaling pathways between LS and the NL group. We can zoom in again. You can see for the CXCL signaling pathways, there are two ligands identified in both datasets, the CXCL12 and the CXCL8. So CXCL12 interact with receptor CXCR4 and ACKR3. So you can see the red color show the ligand and the receptor expression in the LS group, and the blue color show the ligand and the receptor expression in the NL group. So the widening plot is the last plot function I want to show you in my video tutorial. There are other plot you can use, for example the chord plot. If you want to use the chord plot to compare the LS and NL group, you can look at the online tutorials. So I will stop from here for today's video tutorial. So if you are new to my channel, please subscribe my channel and also share my videos with your friends. I hope my video tutorial can help your data analysis. Thank you and see you next time.